Okay, now we're going to figure out the hydrostatic force that's acting on this plate right here. And this is a square, but you just tilt it this way, so it looks like a diamond. And as you can see, I did put on the right angles right here, and we also have 4 feet, right? This is a square, all right? And this is similar to the one we just did earlier. From the water surface to the middle of this square is still 10. And based on a look, which one do you think we will have the bigger hydrostatic force? Is it this picture, or when you have the picture right here, the usual square look? So you should think about it first, and then we'll show you guys how to do this one. This is much harder, and pay close attention to this. All right, so hydrostatic force, you know, pressure times area. Pressure is distance times density, and let's care about the area first. And for area, same business. We have to consider horizontal slices, right? And let's do that first. And let me just draw a picture. Yes, I haven't drawn my reference frame yet, but let me just do this for you guys. So here I have my horizontal rectangle. And as you can see, I'm going to put on y-axis in the middle, x-axis maybe right here, but let me just put down y right here, dy here first for you guys, right? And if I put down the y-axis right in the middle, here I will have x, but I want to go from here to here, so that would be 2x, isn't it? Right, so that's a look. But here's the trouble. This side is slanted this way with a slope. But once you get down to the bottom here, well, you have a different slope. You have a different equation for the x and the y and things like that. Therefore, the way to handle this is that we have to cut into 2 parts. So this is going to be broken apart as, well, the top triangle first, like this, so that we can find the equation of this side right here. It's a line, right? And we are just going to find the hydrostatic force on this first, and we'll add it together with the hydrostatic force down below with the bottom part here, okay? So that's a strategy of doing this problem. You must break down into the top triangle and the bottom triangle. And still, this is 4 feet, and this is 4 feet, all right? Anyways, let's focus on this one first, and I will draw my reference frame. And you should have seen the previous video. It doesn't really matter where you want to put the reference frame, but let me tell you guys the one that I wanted to use. I'm going to put down my reference frame. This picture here, it will be my x-axis, and I will, of course, go like this for my y-axis, okay? And I just want to consider this part here. And now I will put down my horizontal slice, that red rectangle, and now I can tell you this is dy, and you see from here to here is x, but altogether it will be 2x, right? So I'll put down 2x right here. Okay, so if you want to talk about the area, we can get it right away. We can just put down dy times 2x. That's great. And notice that, yes, x is not inviting in the y world, but we'll fix that later on. Don't worry about it yet. And let's go ahead and put on the density, which is once again feet, so we have to multiply 62.5, the US unit for the density of the water. And next, we have to talk about the distance. Well, from the water surface to the bottom here is altogether 10. That's great, right? So, as usual, from the x-axis, and you draw the vertical distance to here, this will be the y distance, right? That's y. But for the distance, we need to find out how far down we are underneath the water. So we have to go from here all the way here. Altogether is 10. This much is y, so that means this right here, it will be 10 minus y. That's all we have. So I have to multiply this by 10 minus y. That's it. And of course, I can tell you guys this is the force of the top one. So I'll just put down the top triangle. And we have to use integration to add all the possible ones. All right, so for the red rectangle, you know it begins with y equal to 0 down here. So I'll just put down, here I have my 0, okay? And now we have a small trouble. In fact, we have 2 troubles. The first trouble was the x. And now the second trouble is, okay, here's 0, that's okay, but how about what's here? We only know this part right here is 4, but we haven't figured out what's this vertical distance, isn't it? So what can we do? Well, we have to do more geometry with this picture, and I will do it on the side here for you guys. If you would like, you can just first turn this square, not the usual look. I will do that for you guys first. So let's look at, here is the usual look of a square. Each side is 4, right? And let me not put down the unit, let me just say this is 4. Okay, this is the diagonal, and both diagonals are equal. So let me just draw this one right here for you guys. Let me just draw this right here for the diagonal. As you can see, we form a right triangle already. This side is 4, this side is 4. What's the hypotenuse then? Well, we can just take the square root of 4 square plus 4 square, and you can work this out real quick. 16 plus 16 is 32, and you take the square root of that, and you can simplify this. You get 4 square root of 2, isn't it? So that's pretty much it. And of course, if you want to tilt this back like that, you can see this is the same as this picture. And once again, my drawing is not the best, so just excuse me on my drawing. Turn this way. This vertical distance, it will be 4 square root of 2, isn't it? But I care about just halfway, right? And you see this right here, if you just want to care about the halfway, just cut this into half. Therefore, you see this is 2 square root of 2. So that means this vertical distance here, it will be 2 square root of 2, okay? And likewise, because this is square, so it's very, very nice. This is 2 square root of 2, and this right here, from the center to this, it's also 2 square root of 2. Likewise, 2 square root of 2 here, 2 square root of 2 right here as well. Okay, so look at this picture, okay? And now, this much will be what? This 2 square root of 2, isn't it? So let me label this right here. This is going to be 2 square root of 2. So y goes from 0 to 2 square root of 2, okay? And here is the trouble we haven't fixed yet, is the x. X is not invited in the y world. So let's go ahead and take care of that issue. And I'm not going to compute the integral for you guys because just do it on your own and then leave a comment down below for the value, alright? I'll show you guys a setup. That's the most important part. Anyways, let's look for the x. On the side here, you see this is a line. We can figure out the equation of the line. Once again, this is 2 square root of 2. We got that. And from here to here, it's also 2 square root of 2 because we did that right here, right? That means this point has the coordinate 2 square root of 2 comma 0. X value is 2 square root of 2 and the y value is 0. This point, as we discussed earlier, the x value will be 0 and then the y value is 2 square root of 2, right? Okay, how can we find out the equation of the line with 2 points? Well, the good old-fashioned way, isn't it? Let me see, where can I put that? Let me just squeeze in right here probably. Let's see. For the slope, let me do this as x1, y1, and this is my x2, y2. So the good algebra, you should know how to do that, right? Anyways, y2 minus y1, which is 0 minus 2 square root of 2, over x2 minus x1, which is 2 square root of 2 minus 0. You get -1 altogether. And in fact, you know this is the slanted 45 degrees, -1. That's fine too. And I will show you guys a quick way to do this. Y is equal to mx plus b, and the b is the y-intercept. Therefore, you know y is equal to -1 for the slope, m, times x, and the b is 2 square root of 2. So we add it with 2 square root of 2 for the b, just like that, all right? And I need to solve for x. So that means I have to just say this is, let me just bring this to the other side. We have -x equals to y minus 2 square root of 2, right? Bring this to the other side. And divide everything by -1. So you have x equals to -y plus 2 square root of 2. Okay? So this is just a good algebra. So just do that on your own. Okay, so at the end, I just have to plug in this into this x. That will be the setup for this integral. So let's do that. 0 to 2 square root of 2, and then this is 10 minus y, and then 62.5 times this 2 times the x. As I said, it's that. Let me put it down in red so it make it more special. Negative y plus 2 square root of y, like this, and then this is with dy. And if you would like, leave a comment down below. Tell me what's the hydrostatic force for the top triangle. So do that whichever way that you would like. Use a calculator. That's all I need from you guys, for my students. Okay, so that's a setup for this one. And before I show you guys the next one, you should pause the video and try to figure out the one right here. All right? So I assume you guys will do that because you guys are good students. Okay, now for this one, I will choose a different reference frame because if I choose this way, it's actually easier. You can still do it right here, but you have to do 10 and then plus y. It's slightly harder. Anyways, what I'm going to do is I will choose the bottom here as my horizontal x-axis, okay, all the way down here. And from here, of course, that will be the y. All right, so now, as you know, still usual business, you draw the red rectangle, and same picture. Pretty much, you have dy, and the width is still 2x. No problem on that, right? And let's just do it right here if you would like. Let's say you have dy, and then you have the 2x, and then you still have the 62.5 for the water density in the US unit. Now, let's take a look of what the distance is. So here, let's refer back to this picture. This is also 2 square root 2, right? Keep that in mind. And that's this much. When we had the 10, it was from the water surface to the middle of the square. So from here to here was 10. But as you know, we have to calculate it from the horizontal x-axis. You know from here to here, this is my y. I have to figure out what's all the way from here, the water surface, down here, right? Once again, from here to here is 10. This much is 2 square root of 2. So altogether from here to here is 10, and you add it with 2 square root of 2. But I cannot combine them. I'll just leave it as how it is. 10 plus 2 square root of 2. With that being said, from here, the water surface to the rectangle, it will be the whole thing, which is 10 plus 2 square root of 2, the whole thing, minus this much, which is y. And that's the distance. And that's why I'm going to multiply right here. So let me just put it down. 10 plus 2 square root of 2 minus y. So that will be the distance. Let me just write it down better because I am running out of space. 10 plus 2 square root of 2 minus y, like that. Okay, so this is just the hydrostatic force on this red rectangle. I have to integrate them. And now, you see, from here, the y value is 0. So we go from 0 up to here. This right here, once again, that's from here to here, 2 square root of 2, right? So we have the 2 square root of 2. So that's nice. 2 square root of 2. So this is going to give us the force on the bottom is going to be this. And the x is still the things we have to do, right? So let's do that. All right. This right here is my line. We have to find the equation of the line again. And if you would like, you can say the slope is equal to 1 because this is exactly 45 degrees. Depending on how you want to do it. Anyways, this is the first point, which is 0, 0. This is the second point. It is technically, from here to here, the x value is 2 square root of 2. And from here to here, the y value is 2 square root of 2. So you do this minus that, you still get 1. Seriously, it's just 1. Anyways, m is equal to 1 for this line. And then y is equal to mx plus b. Y is equal to m is the 1. X is just x plus b is 0, because that's the y-intercept. So b is equal to 0. In another word, y is the same as x. X is the same as y. Therefore, I can just show you here the force on the bottom. We put comma, and then this is the force of the bottom. It's going to be, and that was the force of the top red triangle. The force of the bottom is going to be the integral from 0 to 2 square root of 2, and this 10 plus 2 square root of 2 minus y, and I'm going to erase all this, otherwise I have no place to write down. This right here, times 62.5 times 2 times x. It's the same as y, so that's excellent. So I can just put on y right here, and then we have the y. And let me erase this as well. So that's it. Once again, do this on your own. Okay, do this on your own. Figure this out, and also do this on your own. Figure that out. At the end, the total force, let me just write it down. The total force, I am waiting for your comment. So get to work. Let me know what the answer is. And that is it.